There are always at least two forces acting on every object: gravity, acting downwards, and the normal force, acting upwards, which can be from a road, a rope, or even a table. If the normal force is removed, there's an unbalanced force and the object accelerates downward. It's in free fall. An object is in free fall when the only force acting on the object is gravity. We have gravity pulling the object downward, but we have no upward force there to balance out gravity. Therefore, we have an unbalanced force, which means the object will accelerate downwards, which means the net force cannot be 0 newtons. It's anything but 0. And the object will accelerate. On Earth, it will accelerate at 9.8 meters per second squared. That means the speed goes up 9.8 meters per second each second that it falls. In this free fall lab, we will determine the acceleration due to gravity. In other words, what happens to the distance traveled, the speed, and the acceleration as an object freely falls to the ground. To determine this, we can use a photo gate timer that will accurately measure the object as it passes through the invisible laser and display the data on a laptop as both a chart and a graph. Here is the object being dropped. Let's see that again, but this time with the photo gate timer collecting data. Ah, what wonderful graphs! Let's take a look at the data, beginning with the chart. Anytime you see a 1 as the gate state, that means the laser was blocked. So based on this chart, the object first blocked the timer here at time 0. The object then blocked and unblocked the beam 16 times as it freely fell. The beam was unblocked for the last time at about 0.22 seconds. So it took the object about 0.22 seconds to fall all the way through the timer. The object fell a distance of 0.35 meters in 0.220441 seconds. So it fell at an average speed of 1.587 meters per second. We want to know not just the average speed, but what was happening to the speed as it fell. Let's start by looking at the distance traveled. The data shows the distance traveled by the object is increasing. This distance versus time graph gives us more information. The shape of this graph is a curve. That means the object was covering more and more distance as it fell. This shows an acceleration. Let's check out the chart for velocity. The data shows that the velocity was increasing. This velocity versus time graph gives us more information. The shape of this graph is a slanted line. That means the object was increasing its velocity at a constant rate. That shows an acceleration. The slope of a v versus t graph is the acceleration of the object. So we can determine the acceleration by picking 2 points on the line segment and using the slope formula to find the slope of that segment. After plugging in the values for y and x, the slope of the line is 9.81 meters per second squared. That means the velocity is increasing by 9.81 meters per second each second that the object fell. Now, let's take a look at the chart for the acceleration of the object. The lowest value is 9.77 and the highest value is 9.91. The values are all right around 9.8. The graph shows the same thing. The values are consistently staying around 9.8 meters per second squared. So from this lab, we can see that an object in free fall will accelerate towards the ground at 9.81 meters per second squared.